Okay, this is one of the times that I kind of agree with the picture using the bar method or bar diagram method. And the best reason why I do that is because it shows that they are equal to each other. Okay? So if we read the story up here, it says that, let's see if I can make this bigger so that you guys can see it. Marley's collection is related to Tucker's collection. Okay? And we know that Tucker's collection is 159 golf balls. So that's where this number comes from. His collection is 159 golf balls. Marley's collection is called M. So since this says 3 more than twice Marley's connection, that's where this comes from. We've got Marley's connection once right here, twice right here, and then 3 more. So this shows you that the 159 equals 2M plus 3, which it says it right here. Tyler's collection is twice Marley's collection plus 3 more golf balls. So I do kind of like the visual that it shows that we don't know what it is and we add 2, but they're equal. So let's see if we can make this try it make sense. Okay, so let's do our pieces. Cole buys a new laptop for $335. So I'm going to fill in the cost of the laptop as $335. He makes a down payment of $50. So that's this. And pay the rest in 6 payments P. So we have 1, 2, 3, 4, 5, 6. So these two things are obviously equal. So that's where it comes from. So the cost I'm going to fill in right here is $335 equals $50 plus 6 times P. Okay, so I could fill these boxes in just like so. So that means the equation would be 335 equals 50 plus 6P. They're not telling me to solve it at this point. Could we solve it? Yes. So let's go ahead and solve it. Let's see if it comes out even, because I don't think the book is planning for that. So 335 equals 50 plus 6P. So we'll subtract 50 from both sides. Ooh, I'm going to mess that up. 6P equals 335 minus 50. You can hear me getting my phone out to use the calculator just so that I don't make any careless errors while I am recording. 285. Okay, now we have to move the 6 over. We're going to do that by dividing both sides by 6. So let's see if it comes out equal. 285 divided by 6. It doesn't. $47.50 is what his payments are. So I'm showing you that so that you can see that you could figure it out if you wanted to. But you may not have done that yet. I did 6-2 instead of 6-1 first. Now the question convinced me. Why are both multiplication and addition used in the equation that represents Cole's monthly payments? Well, Cole pays the $50 only once. We're going to call that the constant. It doesn't change. The monthly payments are repeated. And we know that that's repeated addition, and repeated addition is multiplication. So that is why that's there. Okay, we're going to write 2 more two-step equations. A baseball weighs 25.75 ounces less than a bat. Write an equation that represents the relationship between the weights of a baseball and a bat in terms of weights of the box W. So W equals weight of box. All right. So that's interesting. We're going to see this. The box contains 50 bats and weighs W ounces. So we have no idea how much. Let's see where they came up with that. So, weight of one baseball. So we want to know that in terms of a bat. That doesn't. Weight of one bat minus the difference in weight. How do we know the difference? Oh, okay. Because it tells me the difference in weight comes from up here. That's where I was missing it. So the difference in weight is this, 25 point whatever ounces. So the equation 5.25 equals weight over 50 minus 25.75 can be used to represent the relationship between the weights of a baseball and a bat. So this is the weight of a ball equals the weight of bat minus 25.75, because that is, if I told you the bat was 50, then we'd be able to figure it out. That's where it comes from. Okay. We're going to let you guys process that because it's not my favorite. I like it, but it's like this first part is what you need to know. You have to figure out the weight of one bat. How do you figure out the weight of one bat? Well, this has 50 bats and it weighs W ounces. So if I take the 50, or if I have the weight of the bat divided by 50, because that's what the weight of the box divided by 50 tells you how much each bat weighs. If I told you the box was 100 pounds, then each bat is 2 pounds. Because you divided it by 50. So that's where they came from. But they put decimals in there and made it a little confusing for all of us. Let's see if we can figure out the try it. Marcia and Tamara are running a race. Marcia has run 4 kilometers. Marcia, 4 kilometers. Tamara has completed 3/4 of the race. And we do not know how long the race is, I'm guessing. So K is the total length of the race. 3/4 of the length of the race. And is 22.5 kilometers ahead of Marcia. Write an equation that represents the relationship between the distances each girl has run. So, the only one that we knew was Marcia. 4 kilometers. But it must be equal to Tamara at 3/4 of the race, which they're calling K, plus 2.5. So that means those two things are equal. So you will put 4 equals 3/4 K plus 2.5. And at this point, that is all they are asking us to do. We do not have to solve it. So we're not going to solve it this time. Okay, this one wants you to do things a little different again. So one of these is not correct. Claire bought 8 tickets for a total cost of $104. So we've got... the total cost is $104. She had a coupon code to get $3 off each ticket. Let the X be the original cost of each ticket. Which of the following equations correctly represent this situation? So, how many tickets did she buy? 8. So, I am going to divide this into 8. That is 1, 2, 3, 4, 5. That's 4. think that's 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if it cost X, but I got a coupon for each one, that would be X minus 3 inside of each one of these boxes. I hope that makes sense. I'm not going to just save $3 once. I'm going to save $3 8 times because I bought 8 tickets. So, this one is not right because I didn't do, this is not right. This one's not right. But once I drew this picture, I see that I have X minus 3 8 times. And it is equal to the 104 up there. So that explains why this one works. And this is our equation. Okay, let's do the try it. At the mall, Claire buys a hat that is 60% off and socks that are reduced to $5.49. She spends a total of $9.49. So we know that our total is $9.49. Okay. We do not know the cost of the hat. So X equals hat. I know that $9.49 comes from the hat plus the cost of the socks. But I did not pay full price for that hat. I paid 100% minus 60%. And remember, those are decimals. Let me see if I can rewrite that bigger. Hold on. Blech. That's terrible. So sorry. So there's the price of the hat plus the socks, $5.49. Socks, hat, total. But my hat was 100%, which was represented as 1.00, less 0.60x. That would make sense because my unknown is the cost of the hat. So $9.49 equals 0.40x plus $5.49. Do we get that? Yes. This one is wrong because that would be paying 60% instead of paying the 40% that you paid. We saved that money. All right. Now we're going to get into the key concept. It says you can write an equation with more than one operation to represent a situation. So we should be able to get that. We will come back and do the do you understand, or at least parts of them, in a separate video.